All right, guys. So our objective for the day is I'm going to introduce you guys to two special types of logarithms. One is called the common log, and the other one's called the natural log. They get their own special day because they're special logs. We're not really actually learning anything new. It's all the same stuff we've already learned. It's just that it will look a little different because since these are special logs, they get their own special notation. But even that's not even that big of a difference. So we're going to just repeat some of the stuff we've learned in the past two lessons, like changing it from log form to exponential form. We're just going to do it with these special logs. We're also going to do what we did yesterday, use those properties, but with the special logs. And that's it. So let's begin here. So we'll start off by talking about the common log. The common log is called the common log because it has a base of 10. Okay, now why is that special? The number system that is used by pretty much everybody in the world is based on 10. What do I mean by that? Well, here's an explanation. You count from 1, you get to 9, and something special happens after 9. You get to 10, and you get another number added on top of it. And then guess what happens when you get 10 tens? You get another number, a third digit, right? That gets to the hundreds and then thousands. So we have a base 10. Now, just so you guys know, that's not how it's been throughout history. There are cultures who've had based on 12. So they would have a numerical system that goes up to 12. They didn't use the same symbols we did. It was just like one symbol for each one. And then I guess with 12, you would add a new digit, right? So people have done that in the past. It doesn't have to be base 10. Why do we use base 10? I don't know. Maybe it's because we've got 10 fingers. I don't know. But we use base 10. That's what almost everybody uses now. So since base 10 is the most common thing, it works really well with logs. And so this is a common log. And therefore, since he's so common, he's so popular, it's kind of like me. I don't wear my name badge when I come to work because I assume you guys know I'm Mr. Bailey. I don't need my name badge, right? Well, in the same way, this log is so common, he doesn't have to wear his name badge. We don't write the base for the common log. You won't write the base. So, for instance, if you have, you might want to add this, if you have log base 10 of x, well, log base 10 is so popular, he doesn't have to wear his name badge, and so we'll just call him log x. So it's kind of like other things we've seen in math. Like, you guys know if you see an x there, there's a 1 in the front, right? We just don't write it. There's a 1 here. We just don't write it. Or if you're dealing with square roots, there's really a 2 here. We just don't write it. Well, in the same way with logs, since those are all really common things to have happen, they don't get written. Same thing with logs. Log base 10 is so common, we just don't write it. So if you ever see a log without a 10 there, or number, that means it's base 10. Okay? So here's the logarithmic form. Log x equals y. So the exponential form is 10 to the power of y equals x. Right? So you still switch the x and the y. They're inverses of each other. Right? All right, so here we go. Example 1, write this logarithm in exponential form. Notice there's no little number after the g. That's because it's a common log, which means that its base is 10, and it's going to be to the third power equals 1,000. So there you go. So we're just changing it into exponential form. 10 to the third power equals 1,000. So there's one for you guys here. Write this one here on the bottom. Write that in exponential form. I'll give you a second to give it a shot. I want to practice this a little more. I went around and I think I saw one person with the right answer. So I need to be a little bit more clear. So let's see. So first of all, I'm going to ask Badal, what's the base? 10. How do we know that? There's no base there. This is not the base. The base would have gone like right here. There's nothing there. So it's base 10. Now, Let me ask Stephen, what number is going to be the power on this guy? Oh, he's not? I thought I saw. Oh, weird. Damiani. -1. Okay, so the number that's all by itself over here is the exponent, so that goes here. And then let's do Jedrick. What goes here? Yeah. And I mean, is this a true statement, you guys? Yeah, 10 to the -1 is 1 over 10, right? Just like here, 10 to the third is 1,000. So I think we'll practice a little bit more. Let me give you another one here. Log. See if you guys, I'll give you another shot here. See if you could write that in exponential form. Give it a try. Uh-huh.
10 it's 2 equals 100.
Great, okay. So there it is. So we practiced that back in lesson 10.1. But we didn't do it with base 10, but now we are. The only difference is that they just don't have the 10 after the G, but we have to just know if it's not there, it's a 10. Okay? So we've seen these properties before. These are the same properties we learned yesterday. Okay? So, let me see. I hope I wrote this as 10s. I think I did. So we're gonna modify this a little bit, but we learned these properties yesterday, right? Okay, so when these two things match, it's 1. When you have a 1 here, it's 0. When these two things match, but there's also an exponent there, the exponent's your answer. And then we talked about this one, how it's like these cancel each other out and the answer is x, right? Well, what I want you guys to write, I think I meant to put this there and I didn't, so make sure you write this. I wanna rewrite these rules, but with a log that's base 10. So let's put in base 10, it looks like this. The rules are not different, they just look a little bit different. So in base 10, it would look like this. Log 10 equals 1. Now I'm going to write it, but I'm going to erase it quickly afterwards because technically there's a little 10 here, so these match, so the answer is 1. So that's really the same rule here. It just looks a little bit different because there's no base, right? This one, log 1 equals 0. That's literally the same. It just doesn't have the 10 written there. 3, log 10 to the x equals x. And for this one, the base is a, right? So that's 10. So it's going to be 10 to the power of log, and we don't write that, x. So 10 to the power of log x equals x. So it's the same properties, they just look slightly different because we're not writing the base, but it's the same properties. So you just kind of have to train your eyes to get used to it. Okay, so log 10, that equals 1. I think that's property 1. Number 2, notice how there, it's a log base 10. There's a 10 here, so the answer is just going to be the exponent, which is 3x. That's property 3. Correct me if I'm wrong in the properties. Okay, thanks. I'm going to come back to number 3 here in a second, but let's take a look at 4. So 10 to the power of log with a base of 10 is just going to be whatever comes after the log there, so the answer is 4. That's property, I think that was 4. Okay. I'm going to, let me look at something really quick. What, on the student practice, would you guys do number 2 really quick and tell me what property, and I'll ask you what you got. Oh, is it property 2? My bad. Property 2. All right. So I wanted to do that because that's just the basic property thing. Can you find the properties and use them? The other questions that I skipped, I'm going to go back to now. Do you guys see what's different about this one, and this one? They're going to have to be messed around with, simplified, or rewritten somehow before we apply the properties. Okay? All these other ones, they're like property ready. You just apply the property, you got your answer. These guys require some change. For instance, we can't have 100 there, so we're going to change it into a 10. We also don't like fractions, so we're going to fix that. And we also don't like square roots, so we're going to fix that. But we learned how to do all those things yesterday. So let's refresh our minds. So what I don't like about number 3 is that it's 100. My properties don't have hundreds there, right? They're all 10s. But I can change that into a 10. 10 to the what? Second power. Now what property can I use here? Property 3. And according to property 3, the answer would be what? 2. So property 3 says that when you have a log 10 and there's a power here, the answer is just that power. So that's property 3. All right, let's take a look at number 5. The same situation's going on here. I have 100. I don't like that. I don't want 100 there. So I'm going to change it to 1 over 10 squared, just like I did here, just changing the 100 to a 10 squared, but I still don't like it. What do I do about fractions? You lift it up to the top, make the exponent negative. Yeah, so it's going to be log 10 negative 2. And now once again we could do property 3 again. And the answer is negative 2. Mm-hmm.
On our home, it's easy like this, and we just put the answer right away.
If you can see it, yeah. If you can just look at it and know what the answer is, I'm okay with that. A lot of times I do want you to show work on homework, but with these, I actually want to encourage you to be able just to like know the answer. That'd be great. But if you need to show the work, that's fine. But yeah, usually I do want you to show work on homework, but not for these. For these, if you can just know the answer, that's awesome. What I wouldn't like, because you could use a calculator to get all these. I wouldn't like that because then you're depriving yourself of the skill of understanding what logs are. And just letting the calculator do all the work for you. All right, so on this last one here, I have a 10. I like that. So I'm not going to change it this time. But what I don't like is that square root. Do you guys remember what a square root changes into? It's 10 to, not the second power, closer, 1 over 2. So this is a square root, and 10 is just to the first power, so that's 1 over 2. So you change it to a fraction power. So when you have roots, you just change them into fraction powers. Now we can apply property 3, so the answer is 1/2. Okay? So if it's just property ready, like that's a property, that's a property, that's a property, just go for it. These are all just properties. But for these guys, we had to mess with them a little bit. We either had to change the number, or we had to get rid of fractions and radicals, so you might have to adjust them a little bit. Still applies, same stuff from previous lessons. So why don't you guys try 1 and 3 now from the student practice. We already did 2. Try 1 and 3. So that's what we're going to do with the common log today. That's all we've learned about logs so far, and we did with common log. Now I'm going to show you guys the other log. You guys remember this guy here from last chapter? That's Euler's number, and I share with you guys that Euler's number, which is about 2.71, is very useful for exponential functions. It models real life exponential growth better than other things because it models continuous growth rather than choppy growth, like all of a sudden, boom, you get a lot. It's continuously growing. Also, it's extremely useful in calculus. So it's a special base as well. And therefore, since it's exponential, though, if we change it into a log, it would look like this, right? The base goes here, and then these two things switch, so you have that. But since it's such a special base, it gets its own name as well. So this is what we call the natural log. They call it natural not because it's popular like the common base is. Really, that's kind of random. There's no reason why we have to use base 10. We just do, and it's what we've chosen to agree we're all going to do. This, though, is a special thing. This is something where it's like, okay, this is where math becomes cool because it's no longer about just what we feel like doing. This is a number that actually describes kind of like how reason and the universe works. That number's just there. Nobody came up with that number. That number describes exponential growth in a way. We discovered it. We didn't create it. Let me put it that way. So it's a natural number, and so they call it the natural base. So a natural log is a logarithm with a base of e. Okay? So since it's special, when writing a natural log, we don't actually write the word log. We write ln. It doesn't get a little base next to it either, but that's this one's special notation. It's called ln. And you've probably seen that button on your calculator. All that is a log with a base of e. That's all it is. None of the rules are different for it. It just has a special base, so it gets a special symbol. So, logarithmic form looks like this. ln of x equals y. Okay? What would that be in exponential form? Well, the base is not there. It's not written, but it's e. And then we're going to switch the x and y, so it's going to be e to the y equals x. Well, that's another special kind of logarithm, the natural log. So we've talked about two special logs today. We're not learning any new properties or anything. We're just learning how to do the properties with these special logs. Common log, base 10. You don't write the 10. Natural log, base e. We write it as ln. All right. Let's go ahead and do this. Write this logarithm in exponential form. So, I see the letters ln. So what's my base? E. So I'm going to put e. And the power is the one after the equal sign here. So that's going to be 2.08 equals the other number, which there's 8. Okay? And you could check these things. So like, we don't really need to do this right now, but on your calculator, you could do ln of 8. It'll be 2.08 about. I had to round it. And you could also do e to the power of 2.08. It'll be pretty close to 8. Okay? So there you go. This all we're doing is changing it from log form to exponential form. So let you guys try it. Try that one there. ln of 24 equals 3.19. All right, so there it is. So now, after that, we're going to do some properties with ln, but just wanted to be able to transform it so you guys know what ln means. It's a log with a base of e. All right, so let's go ahead and do some of these things here. So now I'm going to rewrite this. I don't want you guys to do this. You can. It just remember, I want you guys to be able to do just do this stuff. I don't want you to have to sit there and think about it. But do you guys know what property that would be?
3.
It's 3. It doesn't look like 3, but it's 3. Let me show you why that's 3. If you want to write this, you can. But ln means I've got a log base e, right? So if I write it like this, maybe that helps a little bit. But you'll never see it written like that. Okay, but ln means log base e. So ln e to the 4th means log base e to the 4th. So now you see, oh, these match, so the answer is So if you want to write this, you can, but I would like you guys to be able to see just from here that that's property 3. That's really log base e. All right. What do you guys think? What property do you think 4 is? Yeah, it's property 4. Now, if you want to rewrite it, instead of ln, what am I going to write? Log e. So now do you see how these match? So that's where they cancel, and the answer is just what? So that's property 4. But once again, I'd rather you don't have to write that. I'd rather just look at it and go, oh, okay, that's property 4. It just looks different, but it's the same thing. So, property 1, the answer is just the exponent. Property 4, the answer is just the part that comes after the x. Now, these are the ones where we have to mess with them because it's a fraction or a radical, but the same rules apply. Nothing different there. What do we do about the fractions? You make it a negative, so it's going to be e to the negative 2. So what's the answer? Negative 2. All right, so I'm going to let you guys ponder for a second. What do you think you do about that? Don't shout it out. I'm going to let you guys think about it and tell me what you think we do with that. I'll ask you what you get in just a sec. If you want to check with a neighbor, you're welcome to. I'll give you about 15 seconds to ponder. What do you think of mine? Yeah. So it's going to be ln of e. This is the denominator, and this is the numerator, so it's going to be 2 over 3. And therefore, the final answer would be 2/3. All right, so it's same properties, just looks funny because it's ln instead of log base e. Right, so I think we have a student practice for that. So I'll let you guys mess around with student practice 4. We'll call on you to share out your answers, and I think that's it for the day if I'm not mistaken. So.